Stretching across continents and beneath oceans, pipelines, they're feats of engineering that fuel the modern world. From transporting oil and gas to carrying water over huge distances, these networks are vital to our infrastructure. Today, we're going to count down 15 of the longest pipelines in the world. Let's start with number 15, the West-East Gas Pipeline. The West-East Gas Pipeline spans approximately 5,400 miles, and it's one of the largest natural gas pipelines in the world. It is located entirely within China, and it transports natural gas from the resource-rich western provinces to the energy-hungry eastern regions. It extends eastward, crossing different terrains including mountains, plateaus, deserts, and rivers, before terminating in major eastern cities such as Shanghai and Guangzhou. The pipeline operates at a depth and pressure designed to optimize its safety, though specific details on the depth aren't publicly detailed. What is known, however, is that it's robust. It includes a compressor station that ensures consistent flow and gas storage facilities to manage supply fluctuations. Construction of the first phase of the pipeline began in 2002, and by 2004 it was operational. This initial segment cost an estimated $5.5 billion, and it was capable of transporting over 12 billion cubic feet of natural gas annually. This pipeline has brought numerous benefits to China. By replacing coal with cleaner-burning natural gas, it significantly reduced their greenhouse gas emissions and air pollution. It's also enhanced their energy security by diversifying the nation's energy sources. However, the project is not without its challenges. The construction and maintenance of such an extensive network have pretty big financial costs. Environmental concerns too have been raised regarding the pipeline's impact on sensitive ecosystems, particularly in desert and mountainous regions. This pipeline employs some advanced technologies such as safety control systems and an IP-based networking to ensure operational efficiency. And another aspect is the pipeline's role in urban energy strategy. For example, in Shanghai, it's been instrumental in transitioning from coal-based power generation to natural gas, which is improving air quality and hopefully reducing the city's carbon footprint. Number 14, the East Siberia-Pacific Ocean. The East Siberia-Pacific Ocean, or ESPO oil pipeline, stands as one of the longest pipelines in the world, stretching about 4,200 miles. Now, to put that distance into perspective, it's about the same distance as driving from LA to New York City and back, with a bit more to spare. The pipeline begins in Taishet, a city in Russia's Irkutsk Oblast. It terminates as a port city of Kosmino on the Pacific Ocean, passing through often extreme terrains. Along the way, it also branches off to supply oil to China, which further emphasizes its strategic importance. From Taishet, it crosses the Siberian wilderness, skirting regions like the Sakha Republic and bypassing Lake Baikal, the world's deepest freshwater lake. The pipeline is buried for most of its length, though exact depth details vary by region. It's got a diameter of 48 inches and initially transported about 600,000 barrels of crude oil a day. That capacity has steadily increased, though, to meet some growing demand, with plans to eventually handle up to 1.6 million barrels per day. The idea of a pipeline connecting Siberia to the Pacific dates back to discussions in the late 1970s. However, it wasn't until the early 2000s that serious plans materialized. In 2001, the Russian oil company Yukos proposed a pipeline from Engarsk to Daqing, China. Around the same time, Transneft proposed an alternative route from Taishet to Kosmino. Well, the Russian government ultimately combined the projects, and construction began in 2006. The first phase of the pipeline was completed in 2009, with oil initially transported to Kosmino via rail. The second phase, extending the pipeline to Kosmino, was finished in 2012. Meanwhile, the spur pipeline to China was operational by 2011, ensuring long-term oil supplies to that nation. Number 13, the Great Man-Made River, Libya. The Great Man-Made River, or the GMR in Libya, is one of the longest and most ambitious pipeline systems in the world, stretching about 1,750 miles. While precise rankings for pipeline length can vary depending on the criteria, the GMR consistently ranks among the largest systems globally. At over 1,700 miles, the pipeline is longer than the distance from New York to Denver, Colorado. Imagine a pipe winding across the United States, supplying water to millions, crossing deserts and navigating political and logistical hurdles. Its scope underscores the challenges of delivering essential resources to arid regions. While the GMR was conceived in the late 1960s and construction began in 1984, divided into 5 phases. Its starting point lies in Libya's southeastern desert, where the water is extracted from the Nubian sandstone aquifer system. Now, this aquifer holds ancient fossil water, estimated to be between 10,000 and a million years old. From there, the pipeline network spans the Sahara, delivering water to urban hubs like Tripoli, Benghazi, and Sirte. The pipes themselves are massive, with diameters up to 13 feet, capable of transporting huge amounts of water daily. It transports fresh water drawn from aquifers that accumulated during the last ice age. Critics, though, highlight that as a significant drawback, cautioning that the aquifer could run dry within 60 to 100 years if extraction continues at its current rates. However, the reliance on a finite resource is a major concern. Once the aquifer is depleted, alternative water sources will be necessary, potentially leading to economic and social instability. The project has faced some numerous challenges, including logistics issues, geopolitical tensions, and the need for massive financial investment. Libya funded the project independently, with costs exceeding $25 billion. International contractors contributed to its construction, and a UNESCO-trained engineer and technician to maintain it. Number 12. The Red Sea-Dead Sea Pipeline. The Red Sea-Dead Sea Pipeline, also known as the Two Seas Canal, was an ambitious project aimed at addressing one of the most pressing environmental crises in the Middle East, the rapid decline of the Dead Sea. Spanning about 112 miles, this pipeline was designed to transport water from the Red Sea's Gulf of Aqaba to the Dead Sea. Although ultimately abandoned in 2021, it remains a compelling example of large-scale planning to combat ecological challenges and meet regional water needs. At its peak, the pipeline was expected to transfer about 220 billion gallons of seawater annually. That's a staggering volume, equivalent to filling over 600,000 Olympic swimming pools each year, and would have made it one of the most significant water transfer projects in the world. The pipeline's route was planned to begin near Aqaba, Jordan, and travel through the Araba Valley before reaching the Dead Sea's Lisan area. Along the way, it would pump water uphill nearly 750 feet before allowing gravity to carry it down towards its destination. The history of the Red Sea-Dead Sea Pipeline dates back to the early 2000s, when concerns about the Dead Sea's rapid shrinkage became increasingly urgent. Over the decades, its surface area had decreased by more than 33%, leading to sinkholes, receding shorelines, and the loss of vital ecosystem. Despite significant international interest, including an estimated total cost of $10 billion, the project faced numerous challenges. Financial constraints, logistic hurdles, and environmental concerns ultimately led to its cancellation in 2021. By stabilizing the Dead Sea's water levels, it could have preserved one of the world's most unique ecosystems, known for its waters and therapeutic properties. The project also aimed to alleviate water scarcity in the region that has long struggled to meet the needs of its population. Number 11. The Trans-Saharan Gas Pipeline. The Trans-Saharan Gas Pipeline, or the TSGP, is a massive project planned to span about 2,500 miles, connecting Nigeria to Algeria. It's also known as the Nigal Pipeline or the Trans-African Gas Pipeline. It's envisioned as a critical infrastructure for transporting natural gas from Africa to Europe. The pipeline begins in the Wari region of Nigeria and travels northward through Niger and terminating in Algeria. From there, it connects to an extensive network of existing pipelines, including the Trans-Mediterranean, Maghreb-Europe, Medgaz, and the Galsi system, which links North African gas to European markets. Now, the pipeline's projected to run through approximately 640 miles in Nigeria, 520 miles in Niger, and about 1,400 miles in Algeria. With an anticipated diameter about 48 to 56 inches, the TSGP is designed to transport up to 30 billion cubic meters of natural gas annually. The pipeline does promise numerous benefits. For Africa, it offers a substantial economic boost by providing landlocked Niger and energy-rich Nigeria with direct access to global gas markets. For Europe, the pipeline is an opportunity to diversify gas supplies, reducing dependence on other major exporters. The environmental advantages, too, are also notable. Natural gas, while still a fossil fuel, produces fewer emissions than coal or oil. The idea of this pipeline, though, dates back to the 1970s. However, progress on the project has been slow due to technical, financial, and geopolitical challenges. The Nigerian National Petroleum Corporation and Algeria's Sonatrach signed an initial memorandum of understanding in 2002, followed by a feasibility study completed in 2006. That study confirmed the pipeline's technical and economic viability. By 2009, energy ministers from Nigeria, Niger, and Algeria signed an intergovernmental agreement to move forward with the project. Initially pegged at $10 billion for the pipeline itself and an additional $3 billion for gas gathering infrastructure. More recently, in 2022, officials from the three nations signed another memorandum to reignite efforts towards its construction. While environmental concerns are another drawback, while the natural gas is cleaner than some alternatives, its extraction and transport can result in methane leaks, a potent greenhouse gas. Furthermore, the construction of the 2,500-mile pipeline across sensitive ecosystems could disrupt local wildlife and habitats. Number 10. The Snowy Mountains Scheme. The Snowy Mountains Scheme, located in southeastern Australia, is one of the most significant and ambitious projects ever completed in the country. Spanning about 140 miles of interconnected tunnels, pipelines, and aqueducts, it stands as one of the largest pipeline systems in the world. Completed in 1974 after 25 years of construction, the scheme serves a dual purpose, diverting water for agricultural irrigation and generating hydroelectric power. The primary function of it is the transportation of water from the Snowy River and its tributaries. This water is redirected from its natural southeast flow towards Bass Strait into the Murray River for irrigation in Australia's inland agricultural regions. The water travels down through the hydroelectric power stations, generating electricity as it falls 2,600 feet in elevation. The Tumut 3 power station, for example, features a 600-megawatt pump storage facility that helps return water to the reservoir, optimizing the flow for both energy and irrigation. Water flows diverted through the scheme provide about 2,100 gigaliters of water annually to the Murray-Darling Basin, which supports Australia's agricultural industry that's responsible for over 40% of the country's output. One of the most significant aspects of the Snowy Mountains Scheme was its international collaboration. The U.S. Bureau of Reclamation provided technical assistance, and immigrant workers from over 30 countries helped construct the system. Despite the ambitious nature of it, it was completed on time and on budget in 1974, at a cost of around $820 million, equivalent to about $6 billion today. Despite some challenges, though, the Snowy Mountains Scheme has proved to be an invaluable asset to Australia. It continues to play a role in the country's agriculture and energy sectors, providing secure and sustainable supplies of water and renewable power. In recent years, the government there has undertaken expansion plans to enhance the scheme further. It's known as Snowy 2.0. This project seeks to add 2 gigawatts of pump storage capacity, build new tunnels and power stations without the need for additional dams. Expected to be fully operational by 2029, Snowy 2.0 aims to improve the reliability of energy supply and further integrate renewable energy into the Australian grid. Number 9. The SR Steel Slurry Pipeline. The SR Steel Slurry Pipeline is one of the most important pipelines in the world, designed to transport iron ore in a slurry form from mines in Kirandul to the plant in Andhra Pradesh. Spanning about 267 miles, this pipeline is the second longest slurry pipe globally, surpassed only by the 396-mile-long pipeline in Brazil. Now, a slurry pipeline works by mixing iron ore with water to create a slurry, which is then pumped through the pipeline to its destination. This method reduces transportation costs considerably compared to traditional methods such as trucks or railroads. This steel pipeline was built to handle up to 8 million tons of slurry annually, which significantly lowers transportation costs. The pipeline's route passes through the rugged terrains of Orissa and Andhra Pradesh, making the project an engineering challenge. The pipeline travels through forested areas and difficult landscapes, which adds to the complexity of the construction and maintenance. One of the key benefits here of the SR Steel Slurry Pipeline is its ability to eliminate the need for rail or road transport. Traditional transport methods often face issues like traffic congestion, wear and tear on infrastructure, and higher carbon emissions. In contrast, the slurry pipeline provides a more efficient and environmentally friendly alternative. The history of the pipeline dates back to the early 2000s, when SR Steel recognized the need for a more cost-effective solution in transporting iron ore. The project was completed in record time, with both the pipeline and the accompanying plant being built in just 2 years. Number 8. Big Inch and Little Big Inch Pipelines. The Big Inch and Little Big Inch pipelines, collectively known as the Inch pipelines, may sound like names you'd give to a pair of cousins, but in reality, they're among the most ambitious pipelines ever built. They stretch for about a combined length of 1,600 miles. Though they no longer hold the title of the longest pipeline in the world, their significance and scale make them remarkable. These pipelines were conceived during World War II as a solution to a critical problem, securing oil supplies for the United States, particularly the northeastern states. Prior to the war, oil was mainly transported via sea tankers, but German submarines were actively attacking these ships, threatening the lifeline of petroleum to the north. To address this, the U.S. government initiated the construction of the Inch pipelines to carry oil through a much safer inland route. The Big Inch pipeline, a 24-inch diameter line, was designed to transport crude oil from Longview, Texas to Norris City, Illinois, and then further on to Pennsylvania. The Little Big Inch, a slightly smaller 20-inch diameter pipe, was built to transport refined oil products, with its journey starting in Beaumont, Texas, and ultimately connecting with the Big Inch in Little Rock, Arkansas. The scale of these pipelines was unprecedented when they were built. At the time of construction, the Big Inch was the longest and largest pipeline in the world, with a length of over 1,254 miles, and was accompanied by 28 pumping stations. This pipeline had a huge capacity, helping to move huge amounts of oil at a time when the country needed it most. The Little Big Inch, which measured 1,475 miles, was paired with its bigger counterpart, wasn't far behind in terms of its capacity. Together, they formed the largest wartime logistics project ever undertaken, requiring thousands of workers, millions of dollars in materials, and cooperative effort between the government and private companies. The Big Inch alone had a massive capacity of 1.2 million barrels per day at its peak, moving oil faster than ever before and ensuring that the northeastern states could remain supplied during wartime. They were critical to wartime efforts, reducing the need for costly and risky sea transport, and their construction stands as an example of what can be achieved under pressure. Moving on to number 7, the Baku-Tbilisi-Ceyhan. The Baku-Tbilisi-Ceyhan, or the BTC pipeline, is a major transportation route that stretches over 1,000 miles, making it one of the longest pipelines in the world, and it holds the position of the second longest pipeline in the former Soviet Union. The BTC plays a role in transporting crude oil from the Caspian Sea region to global markets, connecting Azerbaijan, Georgia, and Turkey. It's become essential not only for its technical scale, but also for geopolitical and economic implications. The pipeline passes through a variety of terrain, including mountain ranges and valleys, with elevations reaching up to 9,000 feet. And along the path, it crosses over 3,000 roads, railways, and utility lines, as well as over 1,500 water sources. At most of its length, the pipeline is about 42 inches in diameter, narrowing to about 34 inches closer to Ceyhan. It operates with a capacity of 1 million barrels of crude oil per day, transporting this resource at a rate of about 6.5 feet per second. The pipeline's infrastructure includes 8 pump stations, intermediate pigging stations, and a pressure reduction station, all of which ensure the efficient flow of it. In total, the BTC pipeline required 150,000 joints of pipe, each 39 feet long, contributing to its weight of 650,000 short tons. Its construction was officially launched in 2002, with work starting in 2003. It was completed in 2005, with the first oil flowing from Baku to Ceyhan in May of 2006. It cost about $3.9 billion to build, and it created thousands of short-term jobs and employed about 1,000 people in its ongoing operation. Economically, the pipeline boosts the region's oil exporting potential, and it offers significant revenue for the countries involved. Turkey, in particular, benefits from the transit fees paid for use of its territory. The pipeline also reduces reliance on the congested and politically sensitive Strait of Hormuz. Number 6. The California Aqueduct. The California Aqueduct is one of the largest, most complex water delivery systems in the world. Stretching about 440 miles from the northern reaches of California to the south, it plays an essential role in delivering water to one of the most populous regions on the planet. It starts at the Clifton Court forebay. It's located at the southwestern edge of the Sacramento-San Joaquin River Delta. From there, it heads south, eventually splitting into 3 major branches. The coastal branch ends in Santa Barbara County, the west branch delivers water in Los Angeles County, and the east branch serves Silverwood Lake in San Bernardino County. A network of pumping stations, including the critical Banks Pumping Plant and the Edmonston Pumping Plant, powers the flow of water through the aqueduct, including a significant lift over mountains where the water is raised nearly 2,000 feet. On a typical day, it can transport around 3.5 million acre-feet of water annually, which is enough to supply about 35 million people and irrigate nearly 5.5 million acres of farmland. Now, the concept of this aqueduct was first envisioned in the early 20th century, but it wasn't until the 1960s that the project truly began to take shape. The construction of the aqueduct was monumental, and it took years to complete, with various parts of the system being built from the 60s through the 70s. The whole system is a mix of open canals, pipelines, and tunnels. While much of the water flows through concrete-lined channels, certain sections of the aqueduct are buried underground to maintain water pressure and prevent evaporation. The channel itself varies in width, with the widest section reaching 110 feet across and a depth of about 32 feet. A recent study suggests that the installation of solar panels over the canal could reduce water evaporation by up to 22 million gallons per mile annually. That could help conserve water, a crucial resource in California's ongoing drought cycles, while also providing sustainable sources of power for pumping operations. The most prominent concern, of course, in California is environmental. The diversion of water from the delta, coupled with the intense pumping required to move the water south, has led to the decline of certain fish populations and other disturbances. Over the years, land subsidence has also been a problem along parts of the aqueduct, as the land sinks due to the weight of the water and the lack of natural groundwater replenishment. Number 5. The Trans-Siberian Pipeline. The Trans-Siberian Pipeline. It's one of the longest and most significant natural gas pipelines in the world. It stretches over 5,100 miles across Russia and parts of Ukraine, and it was designed to transport natural gas from Siberian fields to Europe. As part of Russia's vast network of pipelines, it's played a critical role in meeting the energy demands of European countries. However, in 2024, Russia ceased exporting natural gas through this pipeline after Ukraine did not renew the contract. The pipeline begins in the Urengoy gas field, one of the largest gas reserves in Siberia, and travels southwest across Russia and Ukraine. It passes through regions like the Ural Mountains, the Carpathian Mountains, and it crosses over more than 600 rivers, including the Ob, Volga, Don, and Dnieper rivers. Its original capacity was 1.1 trillion cubic feet, or 32 billion cubic meters of gas per year, though this capacity had decreased by 2009 to about 990 billion cubic feet, or 27.9 billion cubic meters. The pipeline is equipped with 42 compressor stations, of which 9 are located in Ukraine, ensuring the continuous flow of gas across the distances. Its diameter measures about 56 inches, allowing it to transport huge volumes. Now, interestingly, the pipeline is equipped with telecommunications and protection systems, which help to monitor the flow of gas and ensure its safety. The system is supported by 85 dual CCTV stations to maintain security and functionality. The idea for the pipeline was first proposed in 1978 as part of an effort to expand and export natural gas from the Siberian fields. Construction took place between 1982 and 1984 with the help of international financial support, including credits from German, French, and Japanese banks. By 1984, the pipeline had successfully linked the gas field in the Ukrainian border, where it could serve the needs of Central and Western Europe. By the late 80s, however, it was considered one of the longest and most strategic pipelines globally, but after the dissolution of the Soviet Union, its operation became a point of geopolitical tension, particularly with Ukraine, as both countries were involved in the transit of gas to Europe. For Russia, it's been a major revenue source, providing natural gas to the European markets. For Europe, it's offered a reliable energy source essential for industries and homes. The pipeline helps stabilize energy flows to countries like Germany, France, and Italy, making it a critical piece of infrastructure. However, there are also drawbacks to the pipeline's existence. First, it's become a source of political friction between Russia and Ukraine. Disputes over transit fees, gas prices, and political differences have led to temporary halts in gas flow, resulting in energy shortages in Europe. The pipeline's reliance on crossing through Ukraine has been a key vulnerability, and with Russia halting its exports through this route in 2024, the geopolitical landscape has shifted significantly. Number 4. The Keystone Pipeline. The Keystone Pipeline is one of the most ambitious infrastructure projects in North America, spanning 2,680 miles across Canada and the U.S. It was designed to transport crude oil from Alberta's oil sands to refineries and storage facilities in the U.S. This pipeline represents a critical component in the region's energy infrastructure. The pipeline system was formerly known as TransCanada as part of an effort to create a reliable and cost-effective route for Canadian oil to reach major refining hubs in the U.S. Construction began in the early 2000s and unfolded in 4 distinct phases, each expanding the system's capacity and geographic reach. The first phase, completed in 2010, stretches from Alberta to Nebraska and onward to the Patoka Oil Terminal hub in Illinois. This segment, spanning over 2,100 miles, incorporates both newly constructed pipelines and repurposed natural gas infrastructure in Canada. In 2011, the second phase extended the pipeline southward, connecting Steel City to the oil hub in Cushing, Oklahoma, via a 291-mile section. The third phase, completed in 2014, added a 435-mile route from Cushing to Nederland in Texas, allowing crude oil to flow directly to Gulf Coast refineries. The Keystone Pipeline primarily transports 2 types of crude oil, synthetic crude oil and diluted bitumen, the latter being a mixture of heavy crude oil and lighter hydrocarbons that allow for easier flow through the pipeline. With a maximum capacity of 830,000 barrels a day, that's equivalent to approximately 34.9 million gallons, this system is designed to handle large volumes of oil efficiently. Constructing a pipeline of this scale required immense coordination. Steel pipes measuring 30 to 36 inches in diameter were buried beneath a variety of terrains, including prairies, riverbeds, and environmentally sensitive areas. Sophisticated monitoring systems were installed to detect any potential leaks or irregularities, ensuring that the pipeline operates as safely as possible. Its integration with major oil hubs like Cushing, Oklahoma, it's often referred to as the pipeline crossroad of the world. This connectivity allows the Keystone Pipeline to serve a dual purpose, transporting Canadian crude oil to the U.S. refineries and distributing domestically produced light crude oil from regions like the Bakken Formation in North Dakota. Its total length, comparable to a journey from New York City to Los Angeles and back, makes it pretty damn long. It crosses multiple U.S. states, including Montana, South Dakota, Nebraska, Kansas, Oklahoma, and Texas. Number 3. The TransCanada Pipeline. The TransCanada Pipeline is a sprawling natural gas pipeline spanning Alberta, Saskatchewan, Manitoba, Ontario, and Quebec. The system has pipes up to 48 inches in diameter, forming the backbone of natural gas transport across Canada. As the longest pipeline in Canada, and once the longest in the world, its construction marked a turning point in the nation's energy sector, addressing the burgeoning energy demands of a rapidly growing population in the 1950s. It was incorporated in 1951. TransCanada Pipelines Limited was established to construct a natural gas pipeline that would connect Alberta's rich gas reserves to the major urban centers of eastern Canada. The path to construction, however, was fraught with regulatory hurdles. Alberta, home to the gas reserves, initially resisted granting permission for gas exports, citing concerns about ensuring a 30-year supply for domestic needs. After lengthy negotiations, Alberta approved the project in 1953. This paved the way for the pipeline to merge with Western pipelines, addressing political and economic challenges while also securing federal backing. Despite this progress, though, the project encountered skepticism from the U.S. Federal Power Commission, which questioned Alberta's gas reserves and the pipeline's financing. Those challenges, however, only highlighted the resolve of the Canadian government to bring the project to fruition. Construction of the pipeline began in earnest in 1956, marking a monumental engineering effort. In just 3 years, workers installed 2,175 miles of pipe, stretching from Alberta to the eastern cities of Toronto and Montreal. Blasting through solid rock required innovative techniques such as drilling 8-foot deep holes at close intervals and using dynamite to clear stretches up to 1,000 feet at a time. Despite obstacles, though, the pipeline progressed pretty swiftly, with gas service reaching Winnipeg by 1957 and extending to Toronto on October 1958. With its immense scale, the TransCanada Pipeline transformed Canada's energy landscape. It's capable of transporting huge quantities of natural gas to power homes, industries, and cities. It played a crucial role in supporting their economic growth during the mid-20th century. But its significance extends beyond its economic contributions. Its all-Canadian route symbolized the country's commitment to maintaining control over its natural resources, fostering a sense of national pride. Moreover, its construction showed Canada's ability to overcome technical and logistical challenges on a massive scale, setting a benchmark for future infrastructure projects. Number 2. The Druzhba Pipeline. The Druzhba Pipeline, whose name fittingly translates to friendship, is one of the longest pipeline networks in the world. Constructed during the height of the Cold War, it symbolized the economic and political ties that bound the Soviet Union to Eastern Europe, providing a steady flow of oil that powers industries and economies. It spans about 2,500 miles in Russia's Tatarstan region to countries across Eastern and Central Europe. The pipeline's origins date back to 1958, an agreement with the Council for Mutual Economic Assistance, the economic bloc of socialist states. This project's construction began in 1960 and was completed in October of 1964. Built to transport oil from the resource-rich fields of western Siberia, the Urals, and the Caspian Sea, the pipeline was envisioned as an artery of both energy and cooperation. Its network branches into northern and southern routes, delivering oil to countries like Poland, Hungary, Slovakia, Germany, and the Czech Republic. Now, technically, the pipeline is a marvel of mid-20th century engineering. Its diameter varies from 17 to 40 inches, and it relies on 20 pumping stations to maintain a capacity of about 1.2 to 1.4 million barrels of oil per day. The pipeline crosses 45 major rivers, over 200 railways and highways, and goes over multiple countries, making it a logistical triumph. The northern branch of the pipeline travels through Belarus into Poland and Germany, supplying key refineries in Plock and Schwedt. This route also connects to Baltic ports such as Gdansk, facilitating oil exports. The southern branch extends through Ukraine, where it splits into lines leading to Slovakia, Hungary, and the Czech Republic. For decades, the pipeline supported the economic stability of its recipient countries, underscoring its role as an energy source and a diplomatic instrument. Yet in recent years, this network has also reflected the shifting dynamics of geopolitics. Following the Russian invasion of Ukraine in 2022, the pipeline's operation became a point of contention. Germany ceased importing Russian oil via the northern branch in January of 2023, while Poland halted imports shortly thereafter. Despite the disruptions, though, the northern branch began transporting Kazakh oil to Germany in late 2023, demonstrating the pipeline's capacity to adapt to new political and economic realities. In July of 2024, further tensions arose when Ukraine halted the transportation of Russian oil through the southern branch to Slovakia and Hungary, underscoring the fragility of the pipeline's operation amidst ongoing conflicts. These developments do highlight the pipeline's dual role as an economic lifeline and a geopolitical chess piece. Number 1. Colonial Pipeline. The Colonial Pipeline stands as the largest pipeline system for refined oil products in the United States, a sprawling infrastructure vital to refueling the nation's economy and transportation networks. Spanning over 5,500 miles, this immense system delivers up to 3 million barrels of fuel daily from the Gulf Coast in Texas to the bustling New York metropolitan area. The Colonial Pipeline is not merely a feat of engineering, but an essential lifeline that underscores the interconnected nature of energy production, logistics, and consumption. The pipeline was conceived in 1961 and began operations the following year, revolutionizing the delivery of refined petroleum products. The system consists of multiple tubes, including main lines measuring 40 inches and 36 inches in diameter, specifically designed to transport distinct fuel types, such as gasoline, diesel, jet fuel, and home heating oil. Products move through the pipeline at a speed of about 3 to 5 miles per hour, requiring an average of 18.5 days to journey from Houston, Texas to New York Harbor. Strategically placed terminals and tanks that store over 1.2 billion gallons of fuel along its route, those facilities ensure a steady and reliable supply to various communities and industries. Additionally, the pipeline connects directly to major airports, including those in Atlanta, Baltimore, Raleigh-Durham, and it underscores its importance in aviation logistics. The pipeline system is divided into 3 operational districts, each catering to specific geographic and logistical needs. The Gulf Coast District sources refined products primarily from Texas and Louisiana refineries, serving as the pipeline's starting point. The Southeast District, covering Alabama, Georgia, and the Carolinas, contains Greensboro, North Carolina, home to the company's largest tank farm and the terminus of its main lines. From this critical hub, fuel is distributed to the Northeast District, which supplies Virginia, Maryland, New Jersey, and Pennsylvania. Over its history, the pipeline has faced various challenges, including environmental incidents, natural disasters, and cyber attacks. In the 1990s, several spills led to significant fines and a $34 million settlement with the Environmental Protection Agency for violations of the Clean Water Act. Despite the setbacks, though, the company implemented substantial safety upgrades, earning industry recognition for environmental improvements. The pipeline's resilience was tested by hurricanes too, with Hurricane Katrina in 2005 severely impacting operations. Colonial adapted by investing in portable and stationary generators to ensure continuity during future storms. These proactive measures shows how the companies evolved to address any operational vulnerabilities. By delivering fuel efficiently to densely populated and industrially significant regions, it enables economic activity and supports national energy security. It's able to transport about 100 million gallons a day. It underscores its importance as a backbone to the nation's energy distribution network. Thanks for making it through that one with me, guys. I'll see you next time. Thank you to our channel members.